Okay, looking at lesson 4.3 today, looking at sound and how waves and sound work together. So let me share a screen here. Make me disappear so you don't have to look at me. All right. First of all, sound waves are longitudinal waves. So remember, longitudinal waves are when there's a compression and then a rarefaction. So where waves will spread apart, or the medium will spread apart and then get pushed back together, spread apart, push back together. And so they're longitudinal waves. A lot of times we'll draw them as these transverse waves. It's a little easier to show it, but remember all the time that sound waves are longitudinal waves. They have compressions, rarefactions, and they travel through a medium. So there's no sound in space because there's no molecules to compress and to spread back out. So without that, you don't get any sound. Okay, and also light doesn't travel as fast as sound doesn't travel as fast as light. So light will travel much faster. But you really got to understand from this slide is that sound waves are longitudinal waves. You will see it sometimes drawn this way, but understand that they're longitudinal waves. They are not transverse waves. Okay, so here are some properties. First of all, sound can travel at different speeds based on the medium that it's traveling through. So sound travels relatively slowly in the air, but that's because the molecules are so spread apart that it takes a long time for one molecule to collide with another one so that they can compress and then spread back apart. Inside the water, it travels very fast because those molecules are close together. The closer they are, the more often you're going to have these collisions and the compressions and the rarefactions. Inside solids, sounds will travel even faster. Here we have steel traveling at 5,940 meters per second, and in glass it's 5,640 meters per second. You can just do an experiment, put your head down on the table, or just clap or knock on the table with your head up, give it a little knock, that. Listen to the sound, then put your ear down on the table and do the same knocking, and you'll hear the sound will be louder, but that's because it gets there faster as it travels through solids. So here we have, in general, fastest in solids and slowest in gases due to the spacing of the molecules. All right, so that's what we just talked about. Next one, properties of sound, a couple of things. There's intensity. Intensity is the rate at which a wave's energy flows through a given area. Right, and that is dependent on the wave's amplitude and then the distance from the sound source. So amplitude, remember, is how high it goes up or down in a transverse wave, and then that energy weakens as it gets farther away from the source. So you basically understand that as how loud is it, and if you've heard a loud source of sound, the farther away you get, the less intensity there is in that sound. And we measure that in a unit called decibels. And down here, if you want to see it, there's a few ranges for decibels and things. Generally, you can get damage at about 80 degrees, or 80 decibels, sorry, and then severe damage as we get higher than that. Okay, and this one just says Larry because that's the voice. When people talk, we talk about 80. So somewhere above 80 to 100 is where we can start to get some ear damage. All right, continuing on. Loudness is a physical response to the intensity of sound modified by physical factors. So loudness is subjective. It doesn't always, we don't measure it scientifically. We just talk about how loud something is. Depends on your ears, depends on how far away you are from the source. Basically, though, it's a measurement of the intensity, but it's a subjective measurement based on the person. Then we have frequency, depends on how fast the sounds are vibrating. And we have pitch. Pitch is a measurement of frequency. And so this basically, high frequency is high pitch sound, and low frequency is low frequency is low pitch sound. So when you listen to something, talk about its pitch, it's a low note or a high note based on how many waves are traveling past at one time. So remember, intensity has to do with amplitude, which has to do with volume. Frequency has to do with pitch, which has to do how high or low a sound is. All right, and that's it for the notes for today. Mostly, again, just vocab. You'll get to do some practice and some simulations as we go.